Now we come into PCBs and something like basic PCB principles and what you can use and what maybe not. Double-sided as probably the cheapest usually nowadays used PCB. If we eliminate one side, even though one side has still a lot of good properties, of course, but two-sided has one very high advantage, very big, that you simply can route it much more easily, and usually you can avoid any jumpers, yes, or wire links when you are using double-sided boards. So it's very advisable to use such kind of board. Now, for example, when you see here cross-section, you can see here a plated through hole. You can go from on the top side. Now when you come into component on your way, you simply can give that signal, place it on the bottom line, then go on and go back to top side. Yes, usually very well-known things. When we come into multi-layer, here becomes or starts quite different world, and multi-layer boards, of course, it's a chapter of its own. It's impossible to say very much in such a short time, but just to mention, you can use inner layers for many various ways. At least for grounding, it's very good to use for example, for power supply. Power supply and grounding in two separate layers. You take it in the so-called inside of your board, and it simply doesn't interfere you at your PCB design. Suddenly you have a much easier design when you can use a 4-layer board, and you can afford to use ground and VCC inside your board, for example. There is some layer stack up. Yes, all of these can be found on the internet. There are many possible ways of layer stack up, but usually there are some thicker boards and then very short or very thin boards called prepreg. And very fast way to create a, so to say, prototype board is production by a dry wave. Dry wave is not so very well known method maybe for many designers, but simply one specified machine specially designed for this purpose, which is able to use usual drills and also milling drills and milling bits, can simply grind out or mill out unwanted copper layer, and within really few minutes you can get a ready-to-use board. Your board from on your table, and all that is necessary is to have an output file, usually ODB++ or Gerber, Excel, and so on from your CAD software. You will load this into software, which usually comes with machine like this on the picture. For example, this concrete is LPKF, and it is extremely capable machine with a minimum spacing of 2 microns, so 0.1 millimeters. It is simply really comparable to a way or to a method of chemical etching. And what is very good, for example, you don't create chemical waste by this method, and of course mainly you have it on your table, and especially for prototyping extremely useful. For example, this concrete type has a repeatability of 1,000 of millimeter. Milling spindle can rotate up to 60,000 rotations per minute. It has automatic tool exchange. This is extremely useful because in real production you need to use several tools, and you simply don't have to stand at the machine and wait until it's signaled to exchange the tool. This concrete machine will exchange it itself, and they simply have to be put into a holder, and the machine will exchange it itself. Many types of bits, drilling and milling bits are used. Basic types are those which have slightly conical shape and those which have a flat, and they are so-called end mill. As we can see on these pictures, one of them makes a line or a groove in a slight shape into letter V, and when using such a tool, very important is also to define the depth of ingress or into engraving into the material. The more you allow it to go to material, to base material, the wider track it will make, yes, or the isolation track. On the opposite side, the flat mill or end mill is fully cylindrical, so it makes the gap which is still uniform no matter how deep it is set to go into the base material. Now you can see some pictures from real life from such a device, and simply on the first tab you load your data from your CAD software, you select necessary tools, and you place them into holder which is dead in the middle of the bottom picture. We will see it soon also in more detail. Yes, on the beginning of the process you see which tools are to be used. You define some basic parameters. You define on which position in a tool holder is which tool used or placed, and in general the process of production can start. What is also good, so these machines nowadays usually have a camera by which you can check during or after the process the real distances or the real situation on your board. You can measure distances, you can measure isolation, and for example, in case you are using conical tools, you can, for example, adjust depth of ingress to increase isolation gaps if you are not satisfied. As you can see on this really microscopic or almost microscopic pictures, the lines are relatively very nice and the edges are sharp, so the machine is really capable of delivering very good results. Here we see a look into the holder of your of tools, and yes, now you can see a video how it changes the tools. What maybe isn't visible or obvious at first sight, the tool holder is a little bit slanted. what defines depth of ingress of a given tool. So according to desired depth of ingress of a given tool, there you place the tool into that position on the very beginning. On the other video, we will see some start of, let's say, outline drilling or milling. On the first sight, it looks maybe like if it was a photo plotter, but of course the difference is it's not something drawn on your PCB, but it is the copper material which is taken away. Here we can also see there is no dust or copper material, some particles or so. Of course, it is because the machine has connection to vacuum cleaner, so all these particles which also might cause problems at making extremely precise lines are taken immediately away. So when you take the board out of the machine, you literally take it almost fully clean, and the only thing you have to do with it is maybe to wipe it with a soft dry cloth and to apply some soldering protective layer. Now we have it also with the sound. I will. Yes. Now I don't see a possibility to decrease the sound, so I will let you go all the video, and then I will go on with my speech. Yes, so here we have seen some milling of practically away all the board. These were outline borders of the whole board. So after this process, the board can be taken out of the panel, and we get a final board. In practical usage, the machine is closed behind acrylic glass cover. This is the video from the producer. In real life, you are not allowed, for example, to use the machine at the open up deck or front deck. Yes, this was the last video which I wanted to show you, but I will also like to show you some simplified process from etching on the back of the PCB producer, and it is I will just show it to you in a second. Yes, when we come here into FQT International, I will try to find the video. The video presentation. How they are manufacturing PCB board. Yes, here we could have seen something like what's called PCB cutout, and maybe it's a good info for those of you who who aren't very experienced at PCBs so far. When you place order into for any experienced PCB producer, so in a majority of cases, he will also provide you a so-called PCB cutout, what is simply a microsection of PCB, usually in 2 or multi-layer boards. It's very good to see it, and it is also something like approval for you that the board has such a stack up which you want it to, and also a confirmation from your PCB producer that he kept the, for example, inner thickness and thickness between layers, for example. Yes, so this is probably all from this website, which I wanted to show you. If we come back to our presentation, this was practically the last slide from our main presentation. Of course, it can't be said everything in such a short time, but we were trying to tell you at least the most important things from our point of view.